Hello, everyone. My name is Doris, and let me introduce myself first. So, so this is my picture. I submitted for the agenda, and which is also my GitHub thumbnail. But actually, because it's Kitty, and no one knows who's Kitty, and it would be accused by maybe Sanrio. So I changed my profile image to this, like reading books from Mark Twain. So, like, I'm the front end and back end developer from the PSE team and currently work for Messi. So today I'll also like introduce some part like high level mechanism of Messi, but not really dive deep into the Messi like technical part. So for the technical part, like I also have a workshop tomorrow 9 p.m. in the building M. So like if you're interested in the technical part, then please come there. So let me like start with the on-chain voting. So like before starting with the on-chain voting, I want to like declare what is voting and why we need voting. So we could imagine that we already encountered so many voting in our lives, such as like collecting opinions for decisions. Like these are some examples, like we're deciding our lunch, deciding the meeting time, or only just like decide where to go or what should I wear. Like this a really like simple opinion collecting. And the most important part for the voting is the election part in the democratic society. So like not only like election for the team lead or the class lead, but also like the president election or public election. It's really like important in the democratic society, right? So in the like big voting, like if we're just voting for ourselves, then it's okay. Like we can vote in any format. But what if like if we're going to vote like for president or for public or for the whole society, that will have a lot impact. So what's important inside? So I think the first one, which is really important, is we should guarantee the correct execution. So to clarify what is the correct execution, I think the first one is tally every single vote. Like we won't miss every vote, like maybe the vote is dropped in the water or something, like it's being skipped or something. So we would have a transparent process to make sure to the public that, oh, the government or the one who tally votes really doing the whole process correctly. And the second thing I think is really important is the censorship resistance. So the first thing is like everyone could vote if you have the ability to vote. Like if you're a baby, then maybe it's not able for you to vote. But if you're an adult and you're like you have a normal like a smart to vote, then you should be able to vote. And your vote won't be canceled by any case. And also won't be modified like in under any condition. And the third thing I think is important is privacy. Like you can also find many articles on the internet like declaring the secret voting's importance. So these will make sure the voting based on personal feeling. So like to make it deeper, to declare it, to explain it deeper, that is like if we're like not having the private voting, then we might affect each other. For example, if I want to vote something same as my friend. Also, it's an important thing to against the coercion. So like if anyone would know who you vote for, then he might like force you to vote for something and he can check it, like can check if you really vote for that option. So the last thing is the collusion resistance. So I think the most important part for the collusion is resistance is not able to prove your ballot. Like, it's similar to the previous one for the private voting, but like, to explain it more, it's to prevent bribery also. Like, for example, if someone would like to bribe me to vote someone, to vote for an option, but he cannot make sure if I really vote for the option or not, then he will not want to bribe me, because maybe the money would be like, he bribed me, but I didn't do the thing he want me to do, and he won't like have the like he won't need to bribe me, because yeah, he will waste his money. So voting has different like formats, and if we're voting online, can we like vote online for the like big elections? So there are several problems. So for the voting online so far, we need to rely on the like third party to tally the results. For example, the Line bot or the Messenger bot. So actually we cannot like know if the four conditions are being fulfilled. So I think that's why we're like, for the public election or national president elections, most of the countries still using the in-person voting. But for the in-person voting, like ideally fulfill the requirements of voting, the four requirements of voting, like because they will like recruit staffs from the public, and everyone could see the transparent process, and to make sure everyone has its own identity to vote, and like no one could stop anyone from voting. But actually, in-person voting has its like efficiency issue. Like, for example, you need a whole day to like conduct this whole process. It's time consuming and also laborious. And also not friendly for those who have some mobility issues. So let's talk about on-chain now. So first of all, what's the feature of blockchain? So for blockchain, it guarantee it's transparent for everyone. Everyone could like verify the transactions on chain, and it's guaranteed to run on a pre-agreed code. So everyone could check the code it's running or the contract running on the blockchain, and no transaction could be skipped or interfered or being like modified. So actually, we can achieve both correct execution and censorship resistance by purely run the voting process on blockchain. So these are some of the on-chain voting applications, and most of them are like doing quadratic founding or quadratic voting. So these just some of them, like there are many of them. So how about privacy and the collusion issues? So for the privacy issues, like when we are voting on-chain, like actually everything is too transparent that my address and what is my voting option is open to the public. So in this case, maybe we could try zero knowledge proof, and I will talk it like later. And for the collusion part, like there are some issues like using on-chain voting. The first of it is the self-voting. It's not only existed in the on-chain voting, but also the online voting, like the Web 2, both in the Web 2 and Web 3 voting, that how you can like clarify this person is different from that one. So maybe we need an identity verification, or we change a way that you vote based on your coin instead of the identity. But that would cause another problem, that is plutocracy. So actually someone like proposed a way called plutocracy to prevent the plutocracy, which is like there is third party like checking the result of the whole voting process. And then if someone want to bribe everyone, like bribe most people to vote for the wrong option, he will need to spend a lot of money, And in the end, maybe the third party still think this is the wrong option. We shouldn't take this result. And actually, the briber actually lost his money. So the most important thing in the collusion is the bribes. Like, like many people actually doesn't care about the results of the voting, but if there's someone who, like, there's benefit inside, or someone won't give money to him or her, and he or she will be easily bribed. So, well, actually, the goal of voting is to reflect the true majority opinion. So how can we, like, achieve this goal? So let's talk about the collusion resistance. For the collusion resistance, the first thing is to make sure every user is a real person, which that we could make sure that this vote result is based on everyone's, like, thoughts or opinions. And the second one is receiptless, and the third one is change key. And I will explain it later, why these two things would, like, lead to the collusion resistance. So we made a MESI recall, the MESI protocol, which is like short for minimal anti-collusion infrastructure. So let me give a brief introduction on MESI. It's proposed in 2019, and the, like, whole tally and processing process is based on the ZK SNARK. So actually it's based on the ZK zero knowledge proof. And the mechanism for it is just as I talked about before, the receiptless and allow key changing. So why receiptless and allow key changing could, like, lead to the anti-collusion? So let's think about the condition. So Alice signed up with pub key A. And Bob wanna bribe Alice to vote option 1. So Alice vote for option 1. And then, well, actually Alice wanted to vote for option 2. So after, like, talking with Bob, she changed her key to public key B and vote for option 2. So in this case, since we're receiptless, so Bob won't know if, like, Alice changed her key or not. So so Alice could actually change her key and vote for the option she wants. So in Bob's vision, in Bob's aspect, actually he won't be 100% sure that Alice really vote for option 1. So that will decrease his willing to bribe Alice. So to go deeper to the MESI process, so the first thing we need to run a MESI is we need a trusted coordinator. So the trusted coordinator will set up everything, including deploy the contracts, and it will, like, filter the one who could sign up in the sign up period by contract, by writing a gatekeeper contract. And then during the sign up period, every user who fulfill the requirements to sign up could sign up with a generated key pair. And after the sign up period, there is a voting period that the users who sign up in the sign up period could vote in the voting period. And the two things they could do is to send voting message and send key changing message. And those messages are encrypted. Only the coordinator and the user itself could decrypt it. And then the coordinator process the messages and tally results after the voting period ended. And in this process, it's like running on the ZK SNARK proof. So it's running on the circuit. So, like, currently, the MESI applications are used for QF, like quadratic foundings. Like, we've already, like, run several quadratic foundings for the Ethereum events, such as ETHLATEM and Kipu afterwards. And, like, in 2023 or 2022, there are several rounds. And We're collaborating with Clear Funds to run the Crowdgetic funding so far. So if you want to know more technical parts, for example, like how we process the message and how we make the gatekeeping contracts, please come to the workshop tomorrow. So these are my reference documents. Like most of them are based on Vitalik's talks, actually. So thanks for listening.
So now we have 5 minutes of Q&A time. Does anybody have questions?
Does the Macy system allow the user to delegate their vote? And if so, how might it prevent bribery for that delegation?
So if the user like bribe you in person like this, maybe it's like useless to use this to prevent the bribing. But if you like running on the internet and someone want to bribe you with some money, well, actually, we just like decrease the possibility for user to bribe, not 100% actually. So if you like being bribed and you are not like doing the key changing and voting for a new option, well, actually, it just the bribe is success, and well, we just want to like decrease the desire for the briber, not 100% prevent it actually. Does that answer your question?
Just to follow up, like I guess from understanding, like it would because it keeps private like the actual vote, like if you were to vote for some proposal, but in a lot of like governance systems, I might not be the one actually voting, like I might delegate my voting power to another party. And I was also wondering if it like if Macy covers that case as well, or if it doesn't.
So you're saying if someone like give my power, for example, my key pair to others, and then some briber collect a lot of key pairs to vote.
Right.
I think we haven't prevented this like condition. Yeah.
And do we have more questions? Thank you so much, Doris.
Thank you.